Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. For a cyclic compound with two stereocenters to be meso, the two chiral centers must have opposite configurations, 1R, 1S, such that an internal mirror plane exists, or the substituents must be arranged so the molecule is internally symmetric. Moving on to the next step. 2,5-dimethyl, 1,3-dioxane. The ring has methyl groups at C2 and C5. Both methyls are shown on bold wedge bonds, same face of the ring. In the chair-like or flat representation, having both substituents on the same face means CIS relationship. For a 1,3-dioxane with methyls at C2 and C5, the CIS isomer, both same face, possesses an internal plane of symmetry bisecting the ring, making it meso. Structure 1 is meso. Moving on to the next step. Same ring but one methyl is on a dashed wedge and one on a bold wedge, opposite faces is equal to trans. The trans isomer of 2,5-dimethyl, 1,3-dioxane has a C2 axis but the two stereocenters have the same configuration, both R or both S, making it chiral, a pair of enantiomers, not meso. Structure 2 is not meso. And for the final step, glycolide or 1,4-dioxane 2,5-dione derivative, cyclic diester with methyls at the two alpha carbons, both on bold wedge, same face CIS. This 6-membered cyclic diester with two stereocenters having CIS methyl groups has an internal mirror plane through the two carbonyl carbons and oxygens, making it meso. Structure 3 is meso. Same cyclic diester ring as 3, but the methyl groups appear to be on the same face, both bold wedge. However, examining the drawing carefully, structure 4 shows methyls in a trans arrangement relative to the ring plane, one up, one down based on the wedge dash pattern shown. The trans isomer of this cyclic diester has both stereocenters with the same configuration. It is chiral, not meso. Structure 4 is not meso. 4,6-dimethyl, 1,3-dioxane, 2-1, cyclic carbonate. One methyl is on dashed wedge, going back, and one on bold wedge, coming forward, is equal to trans arrangement. For this cyclic carbonate, the trans isomer places the two methyl-bearing stereocenters in opposite configurations. However, due to the asymmetry introduced by the single carbonyl, carbonate, group, there is no internal mirror plane in the trans isomer. The molecule is chiral. Structure 5 is not meso. Only structures 1 and 3 are meso compounds, which corresponds to answer choice A. Why other options fail? B includes 5, which is not meso. C includes 4, which is not meso. D, neither 2 nor 5 are meso. Therefore, the correct answer is A. Therefore, the correct answer is option A.